This is Sally. Sally got a dog for her birthday. Her excitement after getting the dog is the stimulus, which is transmitted through her body by the neurotransmitter serotonin. The dendrite is a part of a neuron which receives the serotonin and begins the process in which the electrical signal travels down the neuron. This process is called action potential. Action potential occurs in the axon of the neuron. The axon is a cell with many channels which allow for the electrical signals to travel down the cell. In most cases, potassium and sodium ions are what cause the charges. There is also a potassium-sodium pump, which we will talk about in a second. To begin this process, the sodium-potassium pump is actively working, pumping 3 sodium ions outside the cell for every 2 potassium ions that it pumps in. This causes the exterior of the membrane to be more positive and the inside to be more negative. This is resting potential. Following resting potential, when the sodium channel opens up and the potassium channel closes, sodium ions rush into the membrane, switching the charges and causing the inside to now be more positive, while the outside is more negative. This is depolarization. Once the energy reaches its maximum action potential, the sodium pump closes and the potassium channel now opens. Potassium ions rush out of the membrane, switching the charges back once again. The outside is once again positive, while the inside is negative. This represents repolarization. Once repolarization occurs, the signal returns to resting potential. This sequence of events occurs many times in order to travel along the neuron. When the action potential finally reaches the axon terminal, a process called synapse occurs. As shown in the picture, the axon has an axon terminal which has many vesicles. In the vesicles are neurotransmitters such as serotonin. During synapse, calcium ions are released. The calcium ions allow the synaptic vessels to move and release whichever specific neurotransmitters that it needs to. These neurotransmitters travel across the synaptic cleft and fit into neurotransmitter receptors on the other neuron's dendrites. Overall, action potential allows information to be passed down a neuron, and the synapse allows that information to be passed from neuron to neuron. These processes control all of the activities that we do and allows us to perform our daily tasks in our everyday lives.